Okay, so today we're going to continue chapter 4. We split it in half. We're going to start 6.4, and we've got 6.5, 6.6 left. So 6.4, we're going to cover solving radical equations and inequalities. Okay, so what your goal is to isolate the radical. So whatever is being tacked on, either added or subtracted behind it or multiplied in front of it, then you're going to get rid of that. You're going to isolate, get that radical by itself, whether it's a square root, cube root, fifth root, whatever it is. Okay? Once you get it by itself, so this is already by itself, cube root of 2x plus 7 equals 3. I want to do whatever operation will undo that radical. So if it's a cube root, what will undo that? Raise it to the third. I'm going to cube it. So what I do to one side, I'm going to cube that. I have to do to the other, so I have to cube that. Cubing a cube root just cancels out that radical, and it leaves me with 2x plus 7 equals, now this is the mistake that a lot of people make. It's a minor mistake, but it messes up your whole problem. People will leave this a 3. You are cubing it. So 3 cubed is not 9, it's 27. Okay, then you're going to solve for x. Alright, so subtract my 7, 2x equals 20, divide by 2, and x equals 10. Now, before you box it, you have to check for extraneous solutions. So, extraneous solutions, remember, are where it's an apparent algebraic answer, but when you plug it back in, it's not true for your original problem. Okay, so what we're going to do is we're going to store 10 for x. Y'all remember doing that? 10 store for x. And then you're going to type your cube root, so math 4, 2x plus 7. It gives me 3, so I know that's my answer. We have questions on how I did that? Okay. So with this next one, I've got the square root of x minus 2 minus 6 equals 0. I want the radical by itself. So I need to get rid of this negative 6 by adding 6. So the square root of x minus 2 equals 6. Now I need to get rid of the radical. It's a square root, so what do I undo it with? Squaring both sides. That will undo the radical, leaving me with x minus 2 equals 36. And then you add your 2, and x equals 38. And then we check it. So 38 stored for x, square root of x minus 2 minus 6. Make sure that minus 6 when you're checking it is outside the radical when you're typing it in your calculator. It gives me 0, so I'm good with that. Okay? So my next one, I've got the square root of x plus 1 equals negative 6. What am I going to do? Square both sides. I have a square root. I need to undo it, so I'm going to square both sides. That leaves me with x plus 1 equals 36. It's a positive. Anytime you square something, it's positive. Don't make the mistake of leaving that negative 36. Okay, so then subtract your 1 and x equals 35. So I'm going to take 35 store for x. And I have the square root of x plus 1. Gives me a positive 6, not a negative 6. So that is an extraneous solution, and we mark through it. So you have to get in the habit of checking every single answer. You have to take the time to do that. And why would you not? when you're checking it, you know if you got it right or not. Kind of. Unless it's extraneous. Okay? Alright, next example. 2 times the cube root of x minus 3 equals 4. What do I do? Divide everything by 2. So that leaves me with the cube root of x minus 3. Something I noticed, that's equal to 2. Bless you. Something I noticed with the past 2 tests is people are forgetting, bless you, that index carries down. So do not forget that index, okay? Not only are you going to get points taken off, but then if I get rid of that, then I made it a square root, and I'm going to square it instead of cubing it. So you have to be careful with the details, okay? So if it's a cube root, I'm going to do what with both sides? Cube it. So x minus 3 equals 8. Add your 3 and x equals, and then I check it. 11, store for x. 2 times the cube root, so math 4. X minus 3 gives me 4, so that's good. Do we have questions on that section? Simple. Okay? Now, what happens when I have radicals on both sides? Okay? Well, what I'm going to do, if it's square root on both sides or cube root on both sides, I'm going to raise both sides, just like I did with this, but instead of a constant, I have a radical. Okay? So if I have square root, I'm going to do what? Square both sides. So on the left, that gets rid of this radical, leaving me with 5x plus 3. And on the right, it gets rid of that radical, leaving me with x plus 19. Now, instead of having a one-step equation, I just have a two-step equation. Okay, so I'm going to subtract my x from 5x. That leaves me with 4x plus 3 equals 19. Subtract my 3. 4x equals 16. Divide by 4, and x equals 4. So then I take 4, store for x. Now I have to check both sides. What I need to do is I need to plug it into the left, so square root of 5x plus 3. And that gives me that decimal. Okay, so that gives me 4.8 rounded. Okay, then I'm going to check the right side. You have to check both when you have two radicals. So square root of x plus 19 gives me the same decimal, so I know it's good. Questions on how I did that? Okay. What's the difference between this example and the one we just did? There's a 1 outside. This is the type of problem I said that's going to require you to FOIL. It's going to require you to do some work, okay? Because what's happening is if I tried isolating this and I move this one over, then it's just tacked on to the other side. It's going to be tacked on no matter what, okay? So when you have a radical on both sides with a constant tacked onto it, added or subtracted, you're still going to take both sides and either square it or cube it. Whatever your index is, that's what you're doing. Okay, so I've got square root on both sides, so I'm going to square both sides. Okay, what happens with the side that has the constant added, I have to write that twice. This is where I'm going to have to FOIL. Okay, so I'm going to have the square root of x plus 2, and be neat with your work, plus 1 behind it. And then the square root of x plus 2 plus 1. So I wrote that twice. Equals, do I have to write the right side twice? No, because I have nothing tacked on. That just cancels it out, leaving me with 3 minus x. Okay? So this is where I'm going to FOIL. If I take the square root of something times itself, what happens with that square root? If I took the square root of 2 times the square root of 2, what does that leave me with? Just 2. So if I took the square root of x times the square root of x, that leaves me with x. So if I take the square root of x plus 2 times the square root of x plus 2, what's that going to leave me with? X plus 2. It just gets rid of it. Okay? Then I'm going to FOIL 1 times that is just going to be x square root of x plus 2 plus 1 times that is going to give me another square root of x plus 2. And then 1 times 1 gives me 1. You are going to have to be careful when you FOIL that. Okay? And then equals your 3 minus x. Okay? Then I'm going to combine this. When I combine this, if I take the square root of x plus the square root of x, how many square root of x's do I have? 2. So that just becomes 2 square root of x. So you multiply the first step, but when you're adding, that radical does not go away. So I've got an x plus 2 and 1 I can combine. What does that give me? 3. Plus square root of x plus 2 plus square root of x plus 2 gives me 2 square root of x plus 2. Equals 3 minus x. Did y'all follow me? Okay. I put another example in the notes for us to still practice, because this is going to be where if you mess up, you mess up here, but you're going to have it on your quiz, you're going to have it on your test. So you got to get this down. All right, so now I'm back to needing to isolate this radical. So if I need to isolate that term, what do I do with this x and this 3? I'm going to move it, so I'm going to subtract x and subtract 3. That leaves me with 2 square root of x plus 2. 3 minus 3 cancels. Negative x minus x does not cancel. What does that give me? Negative 2x. Then what do? Divide by 2. Square root of x plus 2 equals negative 1x. Now what do? Square both sides. So here, I get rid of that radical. X plus 2 equals negative x squared is negative x times negative x, which is positive x squared. Okay. Now, when you get this x squared, at this step, you're trying to get x squared plus bx plus c equal to 0 so that you can factor and solve. Okay, so this is why I say there's only one type of problem that's going to give you issues, and it's going to be long, but it's only one of them. Okay, so what I'm going to do is I'm going to subtract my x and subtract my 2. So that gives me x squared minus x minus 2 equals 0. Factoring. I've got a trinomial. So I take factors of my last term to add or subtract to give me my middle. Factors of a negative 2 to give me a negative 1. Would they be the same or different signs? Remember, if this last term, that constant, is positive, they're the same. If it's negative, they're different. So one's going to be positive, one's going to be negative. They're going to subtract. So the only factors of 2 that you have are 1 and 2. I just need to know which one's going to be negative. The 2. So it's going to be x minus 2, x plus 1 equals 0. If you cannot factor that, something simple like this, you need to brush up on your factoring. You need to go back to that chapter where we factored and go practice. Okay, so then I've got x plus 1 equals 0, x minus 2 equals 0, and it better be equal to 0. So x equals negative 1 and x equals 2. Once we get those two x values, we got to check them. Okay. So -1 store for x. And I've got the square root of x plus 2. Then outside the radical, I have plus 1. That gives me a 2 on the left side. So I check the right side. Square root of 3 minus x. Also gives me a 2. That's true, so x equals -1 is good. Then we're going to do the same thing. 2 store for x. I'm going to go up and check the left. That gives me 3. And when I check the right side, that gives me a 1. Is that true? No, so x equals 2 is extraneous. We mark through it. X does not equal 2. Okay, before you flip that paper, I want you looking at that process of what we did. I want you looking at it. I know it didn't click to everyone. Look at it and let me know what questions you might have. No questions? Yes.
You should look at the last part of your calculation.
The what?
Just like the last part.
So when you store your, when I did -1 or 2? Either one. So all you're doing is you're typing the left side. So square root of x plus 2 plus 1. So I write down what the number is. You don't have to do that. But I write it down so you can go back and reference. And then the right side, square root of 3 minus x, gives me that 1. Because they're not equal, the left is not equal to the right, that's what makes this one extraneous. But when I stored -1, they were both equal, so that's why that's a solution. Left is equal to right. Okay? Other questions? All right. So the next example. I've got the square root of 3x minus 8 plus 1 equals the square root of x plus 5. What am I going to do? Square both sides. So I'm going to have to FOIL which side? The left. Okay, so I write the square root of 3x minus 8 plus 1 twice equals, what does the right side give me? Just x plus 5. Okay, when I FOIL, square root of 3x minus 8 times square root of 3x minus 8 leaves me with what? Just 3x minus 8, just whatever's under the radical. Okay. Then I've got square root times 1, so that's just 1 square root of 3x minus 8. Then I do it again. 1 times square root is just going to be square root of 3x minus 8. Now what if that was something other than a 1? What if it was a 2? Then it would just be 2 square root of 3x minus 8. Okay? And then 1 times 1 is 1. Equals x plus 5. Okay, so we've got two things to combine. We've got our -8 plus 1. So 3x minus 7. And then square root plus square root gives me what? 2 square root 3x minus 8. Now again, if that would have been a 2...
Teachers, at this time, would you please release the welding students that were on the list that was sent to your email? Thank you.
Is that any of y'all? Okay, because I haven't checked my email. Okay, if that would have been a 2 here, then you have 2 square root, 2 square root. What would this be? 4. 2 plus 2 would give you 4. Okay, so not every single time will it just be a 1. I want you to be aware that if this number changes, then you have a different coefficient when you add. Okay, but you're just adding coefficients. All right, so that's equal to x plus 5. So what I'm going to do is I want this radical term by itself. So I'm going to subtract 3x and add 7 in the same step. You don't have to, but you can. Leaves me with 2 square root of 3x minus 8 equals negative 2x plus 12. Very good. Then what do? Divide everything by 2. Not just the x term, but everything. Okay, so that leaves me with the square root of 3x minus 8 equals what? Negative 1x plus 6. Okay, last example, all I had was that. This time, I've got 2 terms. So it changes it a little bit. Okay, now, I still have to square this side to get rid of that radical. So I'm squaring my entire negative x plus 6. So what do you think I'm going to have to do with this negative x plus 6? I'm going to have to FOIL it when I square it. Okay? So I'm going to bring that up here. So 3x minus 8 equals, I'm going to write negative x plus 6 twice. And I'm going to FOIL. So negative x times negative x is positive x squared. Negative x times positive 6 is what? Negative 6x. 6 times negative x is a negative 6x. 6 times 6, 36. So 3x minus 8 equals x squared minus 12x plus 36. What do you think I do next? I'm going to subtract my 3x and add my 8. So x squared minus 15x plus 44 equals 0. Y'all follow me? Okay. So factors of 44 to give me 15. 4 and 11. Same sign. So x, what sign is it? Minus 4. X minus 11 equals 0. So x minus 4 equals 0. X minus 11 equals 0. X equals 4. X equals 11. So then we check. So 4 store for x. I'm going to check my left side. Square root of 3x minus 8. Nope, plus 1. That's going to give me 3. And then square root of x plus 5 also gives me 3. It's true, so x equals 4 is good. So then 11 store for x. Square root of 3x minus 8 plus 1 gives me 6. Square root of x plus 5 gives me 4. Not true, so x equals 11 is extraneous. If you get where they're both extraneous, you need to redo your math. Okay? I know that's a very long problem for y'all. But the steps are really not that hard. It's just a long problem. Okay? There's a lot to it. But you cannot just say, you know what, I'm not going to learn this, it's hard, I'll do everything but that, because it's on your quiz, and y'all know y'all's quizzes are weighted at least 20, 25 points apiece. Y'all know that. So it's on your quiz, it's on your test. I'm telling you this now, because I know some of y'all, it gets hard, you'll do everything else but that. Won't put the effort into learning it. You have to get this down. Okay? Questions on that? Yes. Factors of 44. So I've got 1 and 44, 2 and 22, 4 and 11. So I wanted whatever combination to give me that 15. So 4 and 11 gave me the 15. Other questions? Okay. On your worksheet, I know you don't have that much space. So if you need to do that on the back and just wrote on the back or do notebook paper, you can do that too. Okay? But you should be able to identify when you're going to have a longer problem. Okay? Alright, if y'all don't have questions, we're going to move on to solving radical inequalities. These are back to being simple. I didn't give you hard examples for this. Okay, but there's one rule you're going to have to remember. You're still solving like you did before. You're wanting your radical by itself, so you're still doing whatever you need to do. Okay? Remember, so I guess there's two rules. Remember when you divide an inequality by a negative, what do you have to do? Flip the sign. You cannot forget about that. Okay? So if you need to write it, when you divide by a negative number, flip your inequality symbol. Now, the only other rule that you have to pay attention to is when the index is even, so when you're taking a square root or a fourth root, which I think I only give you square root and cube root. So if you have a square root and less than or equal to, you have to do one extra step, which is a very simple step. But you're going to set the value of the radicand, which is the term underneath the radical, greater than or equal to 0, because you don't want that to be negative. What happens when I take a square root of -4? I get what type of number? Not decimal. Imaginary. Okay, I don't want imaginary here. So if I take the square root and my symbol is less than, so it's pointing to the left, then you're going to set whatever's under the radical greater than or equal to 0 when you're done solving. Okay, that's the only specific thing that you're going to have to really remember. Okay, so for this example, I've got 3 times the square root of x minus 1 is less than 12. If you want to sit there and look, okay, I've got an even root and it's less than, star it. That's what I taught my kids to do last year, and none of them really missed this. They went through their worksheet, they recognized all the less than or equal to, and they looked to see if the index was even or odd, and they would star the evens. Then they knew they had to do something extra. So if you do that, you should be fine. Okay? So just solving it flat out, I'm going to divide by 3. Square root of x minus 1 is less than 4. What am I going to do to both sides? Square it. X minus 1 is less than 16. Then what? Add 1 and x is less than 17. But if I chose any number less than 17, say I did -100, then I would get imaginary. So that's why you're going to take that radicand, so x minus 1, set that greater than or equal to 0. Because you want it positive. That's what greater than or equal to 0 is. Add my 1, x has to be greater than or equal to 1. So what I'm going to do is I'm going to take this x is less than 17 and x is greater than or equal to 1, and I'm going to combine them into a compound inequality. Okay, that was like first 6 weeks when we did that. Okay, x goes in the middle. We know x is less than 17. There's half of it. X has to be greater than or equal to 1. So backwards, x is greater than or equal to 1. There's your compound inequality. If it's not written as a compound inequality, you won't get full credit. You can't just box x is less than 17 and x is greater than or equal to 1. You got to put it together. Okay? Questions on that? Okay. Next problem. Would I need to star this one? It's greater than. I don't have to do anything with greater than. Greater than will always work out. Okay? So I'm going to do what then? Add my 3. So 2 square root of x is greater than or equal to 6. Then divide by 2. Square root of x is greater than or equal to 3. And I do what? Square it. X is greater than or equal to 9. So any value greater than or equal to 9 will be true for that. Questions? Okay. Now this next one, am I going to have to do something funny with it? Do I have to do extra steps? So I would need to look, it's less than, but what else needs to happen? Less than and what type of root? Even. Is this even or odd? So I don't have to do anything weird. A cube root, you don't ever do anything weird with it. Okay? So I just divide by 4. Cube root of x plus 1 is less than 8 divided by 4 is 2. What am I going to do? Cube it. So x plus 1 is less than 8. Subtract your 1 and x is less than 7. You can take a cube root of a negative. That's why you don't have to worry about cube roots. It's only square roots. Y'all good with that? Do we have questions? All right. I had said it only takes 30 minutes. I forgot we added this in there. Sorry. Okay. Solving with rational exponents. Okay. You're isolating the base, which is your x raised to an exponent, or a set of parentheses raised to an exponent. But whatever your base raised to an exponent is, that's what you're getting by itself. Okay? So if I'm looking at my first example, 3x to the 2/3 equals 48, what would I do? Divide by 3. So x to the 2/3 equals 48 divided by 3 gives me what? 16. Alright, you are not going to rewrite that in radical form. Okay, what you're going to do is you're going to eliminate this exponent by raising it to its reciprocal. Okay, so I take x to the 2/3. What is the reciprocal of 2/3? Not negative, just 3 over 2. So that's when we do like perpendicular stuff. So just the reciprocal, you're just flipping the numbers. You should be able to do that. Okay, so 3 over 2. And I do that to both sides. Okay, what happens, remember my exponent properties, when I have a power to a power, I multiply. So 2/3 times 3/2 cancels to give me x. But you have to do the reciprocal. Okay? Then 16 to 3/2, that's what I'm going to rewrite. So that's the square root of 16 cubed. Y'all remember rewriting? I just took a test over that. Okay. Some of y'all missed points because you didn't show me the middle work. What's the square root of 16? Plus or minus 4. And then I'm raising that to the third power. So what's 4 cubed? 64. What's negative 4 cubed? Negative 64. So that plus or minus goes with it. Now, could you check that to make sure you got it right? Yes. Anytime you get x equals, you can check it. The same way, store 64, type your left side, should give you 48. Okay? Questions on that? Next example. 7 times x to the 3/5 plus 2 equals 58. Subtract your 2. 7x to the 3/5 equals 56. Divide by 7. X to the 3/5 equals 8. Okay, I'm going to raise my left side to what power? 5/3. That cancels, leaving me with x equals, when I rewrite it, that's the cube root of 8 raised to the 5th power. What's the cube root of 8? What's 2 to the 5th power? 32. You have to show me that middle. You understand this? I don't think this is hard. Do we have questions before we move on to a whole set of parentheses? Okay. So now I've got x plus 2 being raised to the 3/4. So that is what I want isolated. So I'm going to add my 1, and that leaves me with x plus 2 raised to the 3/4 equals 8. I'm going to raise that left side to what power? 4/3. So the exponent goes away, leaving me with what? X plus 2, not just x anymore, x plus 2. Now I'm going to rewrite this, cube root of 8 to the 4th power. So x plus 2 equals, cube root of 8 is 2. So 2 to the 4th power is 16. So x plus 2 equals 16. Subtract your 2. X equals 14. Y'all want to try the next one on your own? What should your first step be? What does that give you? Then what did you do? Raise it to the 3/4. Now, what people do is they think they're multiplying 16 or whatever that number is times 3/4. You're raising it to that so that these will cancel. So x plus 7 equals, that's the 4th root of 16 raised to the 3rd power. Right? 4th root of 16 is what? Plus or minus 2 raised to the 3rd power. So x plus 7 equals plus or minus 8. If you forget that plus or minus, you're missing the other part of your problem. Okay? So subtract your 7. X equals negative 7 plus or minus 8. I'm now going to have two answers. The x equals negative 7 plus 8 and the x equals negative 7 minus 8. So x equals 1 and x equals negative 15. Majority of y'all should have gotten the 1. Y'all just might have forgotten about the negative 15. Y'all good with that? Yes, ma'am.
So I don't know if it's plus or minus.
If you take an even root, so if you're taking the 4th root or when we took the square root, so an even root. So if it's cube root, you don't worry about it. Okay, next example looks like it would be rough, but it's really not. I mean, it's a little bit more, but it's not rough. So what would I do?
Exponent to the square.
It's 1/2, so its reciprocal is 2/1, so I'm just squaring. So that leaves me with 7x plus 15 equals, now I am taking x plus 1 as a whole and squaring it, so what do you think I have to do with that? Write it twice in FOIL. So x plus 1 times x plus 1. So 7x plus 15 equals what? So 7x plus 15 equals x squared plus 2x plus 1. Then I subtract my 7x and my 15. X squared minus 5x minus 14 equals 0. You're factoring. So factors of 14, are they going to add or subtract?
Or yes.
Subtract, because they're different signs. So my two factors, that will give me a 5. Which one's positive, which one's negative? Very good. So x minus 7 equals 0. X plus 2 equals 0. X equals 7. And x equals negative 2. I didn't take the time to go back and check, but you should be checking your answers, making sure you're doing it right. Okay? Questions? All right, you have a quiz over this next class. Okay?